Let's first see the redundancy aspects of the flight controls. In case of a computer failure, the second computer of the same type takes over. Each primary flight control surface is controlled by different hydraulic sources. 2 for the ailerons, elevators, and stabilizer. 3 for the rudder. Each control surface has an independent actuator for each hydraulic source. Each actuator is controlled by a different computer. One actuator for each surface is always in active mode. The other stays in damping mode and is monitored by its associated computer. To simplify the schematic, only some computers and a few of their associated links are shown. We will demonstrate these points in the following Sec 1 failure. Assume you are the pilot non-flying. You are in flight and everything is normal. Click on the forward arrow to activate the failure. On the engine warning display, read the title of the failure. Observe SEC indications on the ECAM flight control page. The 1 and the box around SEC 1 are amber. The 2 of SEC 2 remains green, indicating that SEC 2 has taken over automatically. The indication for the outer aileron actuator, controlled by SEC 1, is partially boxed in amber. This means that if this actuator was in active mode, it would have been automatically switched to damping mode. Here, as it is not the active one, it remains in damping mode. The active actuator, controlled here by Prim 3, is not boxed on the ECAM flight control page. Notice also the spoilers affected by the failure of SEC 1 are shown as faulty. The SEC 1 fault light is illuminated on the flight control panel. We can see that the first action is to reset the faulty computer. The pilot flying will ask you to perform the ECAM actions. Perform ECAM action. SEC 1 is now off. Continue ECAM action. SEC 1 has not been successfully reset. The procedure requires you to switch SEC 1 off. Continue ECAM action. After review and confirmation from the pilot flying, the status page is displayed for review. A green message advises us that we have a degradation in approach capability. You can see in the INOP Systems column that several systems are now inoperative. After review and confirmation from the pilot flying, clear ECAM actions completed. We will now review the other redundancy features and protections we did not have the opportunity to see when performing the previous procedure. In case of complete failure of Prim computers, SEC computers take over. SEC computers provide complete aircraft control in direct law. In the very low probability of SEC 1 failure, it will be replaced by SEC 2, or vice versa. Another case of failure is an elevator fault. In this case, the deflection of the remaining one is limited to avoid excessive asymmetrical loads on the tail or rear fuselage. and to reduce the asymmetry effects. The remaining surface is sufficient to resume normal flight. Provided the appropriate hydraulic systems are available, mechanical control of the THS is always available via the pitch trim wheels. For the rudder, mechanical control via the rudder pedals is always available, even in case of complete computer failure. This is called the mechanical backup. Summary. General rules. If a computer fails, the second computer of the same type takes over. Each primary flight control surface is supplied by at least 2 different hydraulic sources. An independent actuator is associated with each hydraulic source for each surface. Each actuator is controlled by a different computer. For a surface, one actuator is always in active mode, while the others are in damping mode. Ailerons, elevators, THS, rudder. If all 3 prim computers fail, SEC computers take over. If SEC 2 fails, it will be replaced by SEC 1, or vice versa. Mechanical backup is always available using the rudder pedals and pitch trim wheels, provided the appropriate hydraulic systems are available.